Yes, chapter 6 electromagnetic induction, exercise 6.16. See, here it is. Obtain an expression for the mutual inductance for system as shown in figure. ASIF as shown in figure. Okay, yes, you are given in figure. A wire, a straight long wire carrying current I, one square loop having side A is moving with velocity v in this direction, and x is this distance. Okay, yes, you have to find what is equation of mutual inductance. What is equation of mutual inductance? Now see how to obtain equation of mutual inductance. Yes, current is flowing from this wire. So due to current in wire, magnetic field is produced. That magnetic field is linked with this square plate. So some flux is linked with this square plate. Simple. Yes or no? Then yes, you may say that, sir, find magnetic field. Then magnetic flux, we know equation phi is equal to AB cos theta. Phi is equal to AB cos theta. Yes, area of this plate, it is constant. But is magnetic field constant over this square loop? No. Because magnetic field due to such current carrying straight wire is mu 0 I upon 2 pi r. Mu 0 I upon 2 pi r. Yes or no? Yes, it is. So, is magnetic field at this point and at this point and at this point, is value of magnetic field is same? No. Magnetic field is not uniform. Magnetic field is not uniform over this square loop. Over this square loop. Then see what is method. Yes. So to find flux, first of all I will divide this square plate in very small elements. I am taking one element here. Let it is one element. Having this thickness, yes, this side is A and you know it, okay. This thickness is let dy, and this element, it is at distance. This element, it is at distance. Y. It is at distance Y from this straight wire. Clear about this? So see, first of all, I will find flux passing from this element. To find total flux passing from this square, I will integrate it. Clear about this? Okay. So see how to write here. Okay, here magnetic field produced due to wire is not uniform over square loop. So you have to divide this square loop in small element. Okay, yes, this whole square. Okay, like this. This whole square. You have to take each one element. Let it is one element. Okay, so see here magnetic field produced due to wire is not uniform over square root. So take one element of square loop as shown in figure at distance y from wire, and having thickness dy. Clear about this? Okay, so yes, it is one element. Now how to find? See, we have to find flux passing from this element. So first of all, I have to find what is magnetic field. What is magnetic field at this element? So yes, magnetic field due to wire at element. Magnetic field due to wire at element, that is B is equal to, under magnetic, okay, B is equal to, it is mu 0 I upon 2 pi y. Why? Because this element is a distance y from this y. Simple. And yes, what is direction of this magnetic field? Yes, you have to indicate direction. Current is going in upward direction. Yes or no? Yes or no? As this element is in this direction, so current in this direction, element is in this direction. So magnetic field is normally inside. Magnetic field is normal to plane. It is normal to plane of pitch. Clear about this? Yes. B is equal to mu 0 I upon 2 pi y. So therefore, magnetic flux linked with element. D phi is equal to, what is equation of flux? Flux is VA cos theta. Yes or no? Yes it is. Okay, B, yes it is mu 0 I upon 2 pi y. What is area of this element? See, area of this element. This thickness is dy and this length is obviously A. So what is area of this element? Area of this element is, it is A dy. Cos theta, theta means angle between B and A. Magnetic field, it is normal to plane. Area vector A, it is also normal to plane. So what is angle between them? The angle between them is 0. So it is cos 0. Clear about this? So you take, yes, it is cos 0. Okay. Yes, it is easy. Okay, now how to simplify this? Okay, now see how to simplify this. D phi is equal to, therefore D phi is equal to mu 0 I A dy upon, here it is 2 pi y. Here it is 2 pi by 6, first unit is 1, mu 0 IA dy upon 2 pi by. This flux linked with this element. We have to find flux linked with square root. So therefore, total flux linked with square root. Total flux linked with square root. Phi is equal to integration d phi is equal to integration mu 0 I A upon 2 pi y dy. Okay, mu 0 constant, current flowing from this straight wire constant, A, that is length of this square root, it is also constant, 2 pi, that is constant. So yes, how to write this? If phi is equal to mu 0 constant, I constant, 2 pi out of integration. Here it is only integration 1 upon y dy. And yes, integration is with respect to y. Yes. Okay, here it is mu 0 I A mu 0 I A upon 2 pi mu 0 I A upon 2 pi integration 1 upon y dy. Integration is with respect to y, then how to put limit? See, y, what is y? Y is distance of this element from wire. But we have to find what is flux passing from the square loop. Okay, so yes, elements are like this. It is first element, it is second element, third, fourth, fifth, sixth, etc., 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 etc. Means these elements are between these 2 points. Okay, see, this end is at distance x from wire. Yes or no? This end is at distance x from wire, and this end is at distance x plus a from wire. Yes or no? Yes, it is. Okay, one end is at distance x and another end is at distance x plus a. So what is limit? Yes, limit is from x to x plus a. Clear about this? Now, yes, you have to integrate this. So phi is equal to, yes, phi is equal to mu 0 I upon 2 pi a. Okay, what is integration of 1 upon y dy? Yes, it is ln y. Limit is from x to x plus a. It is x to x plus a. So phi is equal to, it is mu 0 IA upon 2 pi. Now you have to put limit ln x plus a minus ln x. Clear about this? And yes, if you know rules of log, then phi is equal to mu 0 IA upon 2 pi. I can write this term as ln x plus a upon x. It is x plus a upon. Clear about this? Okay, yes, I have to find mutual inductance. Then how to find mutual inductance? Mutual inductance. Inductance means flux upon current. Flux upon current. So yes, if it is phi and we bring I this side, then phi pi I is equal to, it is mu 0 a upon 2 pi ln x upon x means 1 plus here it is a upon x plus here it is a upon x. So therefore phi upon I means it is mutual inductance. M is equal to mu 0 a upon 2 pi ln 1 plus a upon x. It is equation of mutual inductance. It is equation of mutual inductance. Clear about this? So yes, it is one important question for you. You have to find mutual inductance of system as shown in figure. Clear about this? Now, yes, what about question B? See how to solve question B. See how to find question B. What is given? If current flowing from wire is 50 ampere, moving with 10 meter per second, and you have to find induced EMF when x is equal to 0.2 meter per second, take E is equal to 0.1 meter. So see, here it is. How to find E? E is equal to, it is B and V. Just on. And V is equal to, it is mu 0 I upon 2 pi x. L means length of conductor. Here you have to consider length of conductor, that is A. So yes, here is A and here it is V. You are given each and every value, mu 0 I 2 pi x A and V. Yes, you can easily calculate this question. Okay, so yes, it is how to calculate this question. Okay, now next question. See, next question is exercise 6.15. You are given an air-cooled solenoid having length 20 cm. Current flowing is A is equal to cross-sectional area 25 cm square. Numbers of turns 50. Current I is equal to 2.5 ampere. T in 10 to minus 3 seconds. You have to find what is EMF. You have to find what is EMF. See how to find EMF. Here. According to Faraday's law, E is equal to, it is d phi upon t. Yes or no? Or yes, I can also say it is phi upon t. What is phi? E is equal to, phi means it is EB cos theta upon t. Yes or no? Yes, it is. You have to find EMF induced in coil itself. Coil. Magnetic field is produced like this and cross-sectional area is like this. So yes, B and A, they both are in same direction. So here I can say E is equal to, it is AB upon T. And yes, phi means total flux. In total flux, as you are given numbers of turns, you have to write N. Okay, because you are given total numbers of turn 50. So yes, you have to write in flux, it is N AB cos theta. It is N AB cos theta. Now, here it is equal to N. Here it is E. B, what is magnetic field due to solenoid? Yes, we know it. Mu 0 Ni upon T. It is mu 0 Ni upon T. So yes, if I want to simplify this, E is equal to N A mu 0. This small n means total number of turns per unit length. Total number of turns per unit length. So I can write this equation as E is equal to, it is mu 0 n square a I upon, yes, it is LT. It is LT. Clear about this? So yes, it is one simple question, exercise 6.15, which is based on equation. You are given mu 0. Why mu 0? Because you are given air-cooled solenoid. Medium in solenoid is air. And numbers of turns, A cross-sectional area, I current, L length, and T that is time. So yes, with the help of calculator, you can easily calculate this question. Clear about this? Yes. Right now. Good morning, students. Chapter 6, Electromagnetic Induction. Yes, we will see one example today. Example 6.8. You are given one frame. See, it is U-shaped frame, which is placed in magnetic field perpendicular to its plane, but this magnetic field is up to this region only, up to x is equal to b, up to x is equal to b. Okay, here it is x is equal to 0, x is equal to b, x is equal to, it is 2. Okay, yes. Here there is one wire which can easily slide between these two parallel arms, Okay, magnetic field is only in this region. Magnetic field is only in this region. In this region there is no magnetic field. In this region magnetic field B is equal to 0. Between B and B. What is your question? This wire is moved from x is equal to c with constant velocity towards 2b. And then from 2b it is moved in its original condition, in its original position, means that is towards x is equal to 0. Again, this wire is moving with velocity v from x is equal to 0 to x is equal to 2b. Then again from x is equal to 2b to x is equal to 0. Then during this motion of wire, you have to obtain expressions for flux, EMF, force and power. Also, you have to draw the variation of these quantities with distance. Variation of these quantities with distance. Okay, see, we will divide this whole region in two parts. How? X is equal to 0 to x is equal to b because there is magnetic field. And x is equal to b to x is equal to 2b because there is no magnetic field. Okay, so first of all I will find flux. We will find flux. Chalo, for flux. For flux. Okay, in region. First, that is from x is equal to 0 to x is equal to b. That is x is equal to 0 to x is equal to b. See, when this wire is moving from x is equal to 0 to x is equal to b, there is continuous change in area. There is continuous change in area. So yes, here at each and every point, if this wire is at, this wire is at this position, for example, it is at this position, and this distance is suppose x. This distance is suppose x. Then what is area? It is x. And length of this wire is suppose L. Then it is x into L. Yes or no? Yes it is. Yes or no? Yes it is. So yes, when it is moving from x is equal to 0 to x is equal to b, magnetic field is uniform. Yes, B is uniform. But area enclosed by this wire with frame keeps changing. Okay, initially wire is here. Wire is moving. So area changes. Yes, this area changes. Clear about this? Okay. So yes, what is flux? When it is moving from x is equal to 0 to x is equal to b, that flux phi is equal to, it is b l x. Why b l x? Hello, why b l x? This equation of flux is, it is a b cos theta. It is a b cos theta. A, area vector, normal to plane. Magnetic field, normal to plane. So yes, here what is area? Area means it is x into L. This x, and length of this is L. Length of wire is L. And B, that is B, and cos 0 it is 1. Clear about this? So yes, phi is equal to, it is B L x. And is it constant or varying? It is not constant. It is not constant. It is varying. It is varying. Clear about this? Hello? Clear about this? Okay? Okay. Yes. In second case, when x is equal to b to x is equal to 2. Okay. So now, when x is equal to b, when x is at b, what happens? If x is here, this wire is here, this wire is here. What is area enclosed by? What is area enclosed by closed loop? It is, this distance is b and this length is L, so it is BL. Yes or no? What is area? BL. Yes, we know that. As we are moving from this region to this region, area keeps on changing. Area keeps on changing. But see, in this region, as there is no magnetic field, in this region, as there is no magnetic field, okay, flux is linked only in this region. Flux is linked only in this region. So what happens? See, here it is. Initially, wire is here. At x is equal to b, at x is equal to b. Then what is area enclosed? Obviously, it is b into L. Then wire is here, at x is equal to 2b. At x is equal to 2b. Okay, then what happens at x is equal to 2b? Again, yes, area enclosed, it is this hole, but in this region there is no magnetic field, means no flux. No magnetic field means no flux. So flux is linked only with this part. So flux is linked only with this part. Do you understand? Do you understand? Again, initially wire is here. So area enclosed is this total area. Okay? Yes or no? Yes. When x is equal to 2b, when wire is at x is equal to 2b, then yes, this whole area. But in this region, there is no magnetic field, means no flux. So flux is linked with only this part, and that is flux phi is equal to, that is flux phi is equal to, it is again AB cos theta. It is, what is A? It is now B into L into B. Okay, and yes, this is constant. This flux is constant. When wire is moving from x is equal to b to this, yes, area increases, but in this region there is no magnetic field, so flux do not increase. Flux do not increase. Clear about this? Clear about this? Area increases, but in this region, as there is no magnetic field, no flux is linked, so flux remains constant. That is BLB, and it is constant. Clear about this? Clear about this? So yes, it is first of all about this flux, And see, as this wire is moved from this point to this point, flux increases. Okay, then from B to B, it will decrease. Here it is varying, and I can write increases. Any doubt? Any doubt? Okay? Okay. Now, it is all about flux. Now, you have to find what is relation of EMI. What is relation of EMI? Yes, how to find EMI? See. Sorry, not EMI, EMF. EMF, electromotive force. According to Faraday's law, electromotive force, E is equal to this minus d phi upon dt. Yes, E is equal to, it is minus d phi upon dt. So is equal to, it is minus, is equal to, it is minus. It is d phi upon dt. Now for region first. x is equal to 0 to x is equal to b. X is equal to 0 to x is equal to b. How to find EMF? How to find EMF? Okay, see here it is. E is equal to minus d phi upon dt. E is equal to, it is minus d phi upon dt. Then minus d upon dt. What is value of phi? It is b l x. B constant, L constant, and dx upon dt it will be minus. So it is minus BLV. It is minus BLV. Clear about this? Okay? Okay. So yes, it is for that. Second, for second region, that is from x is equal to b to x is equal to 2b. X is equal to b to x is equal to 2b. What is value of EMF? 0. Because from x is equal to b to x is equal to 2b, flux is constant. Flux is constant. Okay? Right now we are discussing only this process when it is moving from this point to x is equal to 2b. X is equal to 0 to x is equal to 2b. Clear about this? Okay. Third one, yes, it is EMF. Then how to find equation of current? Then how to find equation of current? Okay, yes, how to find equation of current? Fourth one is current. Third one is current. Yes, current I is equal to, it is E upon R. Current I is equal to, it is E upon R. So for first case, that is from 0 x b. Current I is equal to, it is minus B L B upon R. And for second case, that is B less than x less than 2b. I is equal to, here it is 0 because EMF is 0. Then next one is current, and then it is force. It is force. Force means lens force. F is equal to, it is ILB. F is equal to, it is ILB. Yes, F is equal to, it is ILB. Okay, so yes, for first case, that is 0 less than x less than b. What is force? So force is equal to, it is, yes, what is value of I? It is minus B LB upon R, and here it is LB. So it is minus B square L square B upon R. And for case, that is B less than x less than 2b. What is force? It will be 0 because current is 0. Clear about this? Okay, and last one is power. Yes, last one is power. What about power? So yes, power P is equal to, it is I square. Power P is equal to, it is I square. As it is I square. So obviously, during first case, that is from 0 to x to 2b. Okay, power P is equal to, it is I square R. B square L square B square upon R square. Yes or no? And into R. So it is B square L square B square upon R. And in region, that is from B to 2b. Power P is equal to 0. Power P is equal to, it is 0. Clear about this? Okay, so these are equations. Now we have to draw graph. See how to draw graph. Here it is. Distance, that is x. Here it is of flux. Then distance, here it is graph of EMF. Then distance, here it is graph of force. Then distance, here it is graph of power. Okay, now, yes, it is x is equal to 0. It is x is equal to 0. X is equal to 0 means it is k. Then here it is x is equal to b. X is equal to b. Here it is x is equal to 2b. Okay, see, wire is moving from x is equal to 0 to x is equal to 2b, and then 2b to x is equal to 0. Means up to this, wire is moving outward. Wire is moving outward, and then wire will move inward. Inward means again it will be here at, again it will be here at, again it will be here at b, and then last it will be at, then it will be at 0. Clear about this? That is inward. That is inward. Okay, now how to draw graph? Now how to draw graph? See, here it is. Initially, this wire is here at x is equal to 0. Then x is equal to 0 means no area enclosed. No area enclosed means flux is 0. Yes or no? But as this wire is moving towards B, towards B, towards B, area increases. So area increases, so flux also increases. Flux also increases. Flux also increases. Clear about this? When it is moving from B is equal, x is equal to B to 2B, flux is constant, that we have proved. Flux is constant. Flux is constant. Clear about this? Again, when it is returning from 2B to B, that is in inward, again in this region, flux is constant. Flux is constant. Then again in this region there is magnetic field. So as wire is moving from B to 0, area decreases, then now flux decreases. Flux decreases, and at this point again flux will become 0. So what is outward and inward motion? First of all, wire is moved from x is equal to 0 to 2b, and then 2b to 0. Clear about this? And see, from this case you can easily draw each and every graph without this calculation. How? See, due to change in flux, EMF is induced, and between 0 to b, see what is EMF? EMF E is equal to, it is minus BLV. It is minus BLV. Then how to draw graph of this EMF? Minus BLV. Here it is. When it is moving in this direction, flux increases. So according to Lenz's law, EMF is induced such that it opposes its cause. So EMF produced is like this. It is minus BLV. Okay. Now see, during this region, flux is constant. Then EMF is 0. And now, see, here flux is increasing. So EMF induced is negative, minus BLV. Here flux is decreasing, opposite change. Then obviously EMF will increase like this. EMF will be positive. Flux increases, EMF negative. Flux decreases, EMF positive. So it is graph of EMF. Clear about this? Okay. Yes or no? Yes, it is. Force means Lenz's force. See, between 0 and B, where it is, yes, between 0 and B, force is negative. So yes, its graph will be similar to EMF, because Lenz's force is produced such that it opposes its cause, that is change in magnetic flux. So here it is force. In this region again, no change in magnetic flux, so no EMF is produced, so no force is acting. So again in this region no force is acting, and in this region again it will change its direction. So it is graph of force versus distance. Last one is power. See, in power it is I square, and power, that is loss of it, is always positive. So its graph will be like this. During this power is positive. Okay, here no current is flowing, means no power loss. Here again power will, that is loss of power. Clear? So these are graph. Yes, you have to understand only this first graph. You can easily draw this other graphs. Clear about this? So yes, it is one question which is based on such two many equations and one graph. Okay, again from x is equal to 0 to 2b and then return from 2b to 0. Clear about this? Yes, this is it for today.